A cross section is the shape, the two-dimensional shape that is formed from slicing a three-dimensional object. So you'll see in this picture at the top of your screen, you have a cylinder, but it has been sliced. Well, the cross section that was created here is a circle because that is the two-dimensional shape that you see when it is sliced. So you can have different cross sections for different shapes. And what you need to know is that we can cut in several different ways. So we can cut so that we are cutting parallel to the base. Well, that's what happened here. Because remember, parallel means that you would not intersect the base and you would go straight across because at no point would it ever intersect. So in this case, we cut straight across and we saw the circle. Well, when we cut any shape parallel to the base, the cross section will be the shape of the base. There is another way to cut, which is called perpendicular to the base. When we cut perpendicular to the base, that means that we cut through the top of the figure and all the way down to the base. And we cut it at a straight 90-degree angle. So it cuts perfectly straight. Now, what that would do is give you a different type of cross section. So think about this cylinder. If it was back intact, but we had cut it like this, that would be perpendicular to the base. And then if we opened it up this way, we would not see a circle anymore. We would actually see this part, which would be a rectangle. So when we cut perpendicular to the base, it's usually one of the faces of that shape, but sometimes it might be a little bit different depending on what it looks like. And then we have a diagonal cut. So a diagonal cut or tilted away from the base is it's going to be a cut that sort of elongates part of your figure. So for this one, if instead of cutting this way, if we had cut it a little bit diagonally, well, we'd still see this circle at the bottom, but the circle would have been elongated, so it would look more like this, which we are used to calling an oval. But what we're going to call it now is a more mathematical term, which would be an ellipse. So we're going to look at different shapes today and find their cross sections. All right, so let's start with a cube. So I want you to be on page 46 of your notes packet. And at the top of page 46, it's asking you for the cross sections of a cube. Well, there are a lot of different cross sections for a cube. It's one of these strange shapes that has a bunch of different ways that we can cut. So you see in this case, I'm taking this sword and I'm going to cut the cube. And in this case, I'm just cutting off a corner of the cube. So where it says the cube at the top of your page, there is one box that says one corner. Well, if we cut off one corner of the cube, you can see that the cross section we're left with right here is a triangle. So where it says one corner for cube, I want you to put triangle. All right, so this one is also cutting off just one corner, so you see that you can cut it off again. And even though they moved that sword, that when you cut off one corner, no matter what you do, you're going to still get a triangle. All right, now this is going to be a strange cut. So this could be one that you put for other. So where it says other cut for cube, you can put this cut. Well, when you look, you see I'm cutting through, but in a very strange way. Well, if I cut this and I look at this shape has 1, 2, 3, 4, 5 sides, which means that this would be a pentagon. All right, now this one is going to go straight down. So it's going straight from the top all the way down. This would be called perpendicular to the base. When I'm cutting perpendicular to the base, I'm going to get the face of whatever side I'm looking at. So in this case, when I cut perpendicular to the base, I'm going to get a square. So for perpendicular to the base, I want you to put square. All right, now this is another strange cut. So this was another one that you could put in the other category. So if I cut through at this angle, I would get a hexagon. So this would have 6 sides. So it would be a hexagon. This is another strange cut you can make. Now, this one specifically is kind of going through it diagonally. So if you look, if I go through diagonally, I'm taking the square that was on top or on the side, but I'm elongating it, just stretching it out. Now, when I do that and it's sort of tilted, then I'm not left with a perfect square or rectangle. Instead, I'm left with a parallelogram. So for cube, where it says diagonal cut, I want you to put parallelogram. All right, so for this one, we are going to cut straight through. So we're going to go from one side of this cube all the way down. And so we're going to be taking off 2 corners of the cube. Well, I want you to look where it says 2 corners on your recording sheet. When we cut off 2 corners of the cube, we're left with a rectangle. So where it says 2 corners, I want you to put rectangle. All right, so now we would be back to where we started. So the only one that we did not do here was the one that is parallel to the base. Well, remember, if we're cutting parallel to the base, then we're cutting so that we see whatever shape the base is. Well, if I think about a cube, the base is a square. So I would cut so that if I cut parallel to the base, I would see a square. So for parallel to the base, I want you to put square as your answer. Now we are going to examine some of these shapes so that you can see what these look like and what their cross sections look like. So we're going to start with a cylinder. So cylinder is the first shape in the second table on your page. And we're going to start with perpendicular to the base. So remember, if I'm going perpendicular to the base, that means I'm going through the base. So in the cylinder, the base is a circle. Well, if I'm going perpendicular to the base, then I'm going straight up and down so that I'm intersecting that base. Well, if I do that, if I were to take that cylinder apart, you see that I would have a rectangle. So for the cylinder, perpendicular to the base would be rectangle. Now I also can do parallel to the base. Well, remember, parallel to the base is going to show you the shape of the base. So for a cylinder, the base is a circle, which means if I do a parallel to the base cut, the shape that I see here is a circle. So for parallel to the base for a cylinder, I want you to put circle. And now let's look at a diagonal cut. So for a diagonal cut, we would cut it at an angle. So we're tilting this cut. Well, you see that we had the circle from being parallel, but then we just sort of stretched it out. So because of that, it's no longer a perfect circle, it's more of an oval. So for this, we are going to call this an ellipse. So remember, when you're spelling ellipse, it's E-L-L-I-P-S-E. All right, now let's look at a rectangular prism. So that is the next figure on your page. So for a rectangular prism, if I am going to cut it perpendicular to the base, then I'm going to cut through the base. So I'm cutting like this, and you see that I'm left with a rectangle. So our answer here would be rectangle for perpendicular to the base. Well, if I cut parallel to the base, then I'm also going to get a rectangle because the base of a rectangular prism is a rectangle. So if I cut so that I can see that base, that's what I'll get, is a rectangle. Now, when I do a diagonal cut, then I'm taking this and I'm kind of tilting it, which means it's being stretched. So this is no longer a perfect rectangle because these angles are more than likely not 90 degrees. So instead of saying a diagonal cut being a rectangle, the diagonal cut here is going to be a parallelogram. All right, now let's look at a cone. So for a cone, if I cut it perpendicular to the base, I'm going to cut it straight up and down. So notice this goes through the top and then all the way down so that it intersects the base. Well, when I look at that cut, I'm left with this triangle. So when I cut perpendicular to the base, my cross section is a triangle. Now, if I cut it parallel to the base, then I should see what the shape of the base. Since the base of a cone is a circle, when I cut it parallel, I will see that circle. So parallel to the base for a cone is a circle. Now, just like with a cylinder, when I tilt this circle and do a diagonal cut, you notice that I have the circle, but it gets stretched out. So that makes this diagonal cut an ellipse. So the cross section would be an ellipse here. All right, so now let's look at a rectangular pyramid. And we're going to use that for the square pyramid. We're just going to look at it and think about this bottom as being a square instead of a rectangle. So for this, if I do a perpendicular cut, then so here's the problem with this. If you go all the way over here, that's not actually perpendicular. I have to make sure that I go straight through the top. So I'm going to need to move this so that it goes all the way through the tip and then straight down, and that is going to give me a perpendicular cut. Well, when I do this, you notice that my cross section for perpendicular to the base is giving me a triangle. And that makes sense because when I cut this way, I'm going to see each of these sides, and each side is a triangle. Now, when I change this and I cut it so that it is parallel to the base here is a rectangle, so that would be a rectangle. But on your paper, we're looking at a square pyramid, so imagine that the base here was a square instead. If that was true, then when we cut parallel to the base, we would have a square cross section. Now, when we cut diagonally, we take that square and you see how we're kind of elongating it and we're changing some of those angles. So when we cut this diagonally, we're going to have a parallelogram. All right, now we're going to look at a triangular prism. So with a triangular prism, you have to be careful because you have to pay attention to the fact that the base of a triangular prism is its triangle. So you'll notice on your paper that it's actually tilted in a different direction. But you need to know that if we're cutting perpendicular to the base, then we need to cut through that triangle. Well, when we do that, we're going to see all of these other sides of the prism, which would be a rectangle. So when we cut this perpendicular to the base, we're going to get a rectangle. Now, when we change this and cut parallel to the base, then we are going to move it like this, and it's cutting straight through so that we can see the base. Well, since the base is a triangle, then we are going to have a cross section that is also a triangle. Now, when we tilt this and make this a diagonal cut, you notice that this triangle that we had gets stretched out. So our cross section is still a triangle. It's just more stretched out than it would be. So the diagonal cut for your triangular prism is still going to be a triangle. All right, now let's look at a triangular pyramid. So for a triangular pyramid, if I start with perpendicular to the base, so remember it's got to go through the top. So from the top all the way through, then I'm going to have a cross section of a triangle. If I cut it so that it is parallel to the base, then I'm going to see the base, which is a triangle, so this cut will also be a triangle. And then if I cut it so that it is diagonal, then I will also get a triangle for that. So every cross section that is possible for a triangular pyramid is a triangle, unless you cut it in some very strange way. So all of our typical cross sections for a triangular pyramid will be a triangle because all of the sides are triangles. All right, now the last one is a sphere. So a sphere is very special. The thing about a sphere is I could rotate this sphere and it wouldn't really matter. So I could rotate the sphere, but no matter what I do, no matter how I cut, wherever I go on this, what I'm looking at is going to be a circle. So it doesn't matter how I turn this plane. It doesn't matter how I rotate it, how I cut, no matter what, because a sphere is perfectly round. A parallel cut, a perpendicular cut, a diagonal cut will always be a circle. There is only one possible cross section of a sphere, and that is a circle.